So if we look at the Oracle triggers, there's a stored PLSQL procedure, and it's going to be executed either when the DML operation occurs or a specific event occurs. There's actually 6 DML events, the trigger timings, with the insert, update, and delete. And with that, then, if you look at you can have the timing that's specifying when the action occurred with a before or after. So you could have like a insert, update, or delete with a before-after trigger to fire the DDL statements themselves. So with the before triggers, they're going to run trigger the action before the triggering statement, and with this you could think of using it when it's going to determine whether a triggering statement should be allowed to complete. Using the before for this purpose, you can eliminate unnecessary processing of trigger statements and eventual rollback in cases where the exception is raised in the triggered action. The after trigger then would be fired after the action occurs with the statement. So you can have your before statement trigger, which does the before executing the triggering statement, the trigger action is run. Before row trigger, and with that, before modifying each row affected by the triggering statement, and before checking appropriate integrity constraints, the trigger action is run. And that's if the trigger restriction is not violated. The after statement trigger, after executing the trigger statement and applying any deferred integrity constraints, the trigger action is run. After row trigger, then after it modifies each row affected by the triggering statement and possibly apply an appropriate integrity constraints, the trigger action is run for the current row, providing the trigger restriction was not violated. Unlike the before row triggers, the after row trigger locks rows. You can have multiple triggers of the same type for the same statement for any given table. So, for example, you can have 2 before statement triggers for an update statement on a table, and then multiple triggers on the same type of permit modular installation of applications that have triggers of the same tables. The key thing about using triggers that allows controlling invalid data, and you're looking at implementing using the business rules and generating values. This is just general information about the process to set it up. You'd use the create trigger. Key thing to keep in mind is that the executions, when you have multiple triggers, is going to be in a certain order. Your statement level triggers before column level triggers, before triggers occur before the after triggers. With that, you have your user triggers that are data dictionary view, and all triggers are created on a table, and the table can have unlimited triggers, and do not overuse. Key thing is not to overuse them, because once again we get back into the look at performance and use of resources. When we look at the SQL Server triggers, you're going to use the create trigger DDL statement to create the trigger. The conditions will either prevent a trigger from firing, or you can look at the update in the columns update functions. With the logical tables, then you have the deleted, that's containing the original data, and then the inserted, that's going to contain the new data. With that, then there are some restrictions that you need to keep in mind on how these function. The following are restrictions, and with that, the transaction SQL statements that are not allowed are the alter and the create database, the INI, and the resize for the disk, dropping and loading database, which makes sense, and the load log. reconfiguring, restoring, or restore log. This all makes sense, though, if you think about it being a transaction SQL statements.